What's up everyone, welcome back. Patrick here, moving on to the next example dealing with combining functions. In this specific example, we're going to talk about composite functions. So notice that we're not adding the f and g or subtracting it, or it's not f over g. We got f of g, which is sometimes symbolized by this open dot here, and I'll get into more specifics what that means. Where we got g of f, or f of f, and g of g. So we got these four functions that we got to state, given that f of x equals the square root of x minus 2 and g of x equals x plus 5. And then we got to state the domains of each function. So let's start off with this f of g. So if you see something like this is the exact same as f of g of x. Like that. This and this are the exact same thing. So what we can do is we can rewrite this as f of what is g of x. G of x is x plus 5. Okay, so we know that f of x equals the square root of x minus 2. And really what we can do is we can generalize this further. If f of x equals the square root of x minus 2, then f of any expression is equal to the square root of that expression minus 2, which is what we're dealing with here, because notice that in the bracket we don't have an x, we have an expression. So we can rewrite this, f of x plus 5 is going to be that expression, x plus 5, minus 2, which is going to equal, notice the 5 minus 2, that simplifies to 3. So this ends up being the composite function. That's f of g of x, or f open dot g. Both mean the same thing. So that's the final answer. What's the domain for it? Well, we just have the square root of x plus 3. Remember, anything under a square root expression, as long as it's not in a denominator, has to be greater than or equal to 0, which means x is greater than or equal to negative 3. And so the domain, in a nicer format, x can be anything as long as it's greater than or equal to negative 3. In interval notation, we would say x is an element from negative 3 in square brackets to positive infinity, like that. Now let's move on to the next one. So here we got g of f. So if we got g open dot f, that's the same as g of f of x. Both of those mean the same thing. So what we would have is g of, what's f of x? Square root of x minus 2. And notice that g of x equals x plus 5. And if we generalize this, given that this is the function, then we know g of any expression is going to be that expression plus 5. So applying this here, g of this expression is going to be that expression plus 5, like that. And we can't simplify that any further, so that there is the function for g of f. And notice that here, the domain, x minus 2 has to be greater than or equal to 0, so x has to be greater than or equal to 2. And so the domain would be XER, x is greater than or equal to 2, or in interval notation we would say x is an element from 2 to positive infinity, like that. Right, so notice the difference between f of g, like this, and then g of f. Very different functions. So now let's move on. Let's do f of f. So what's f of f going to be? Well, that's the same as f of x. Right? We're just taking that same function and putting it into, we're taking a function and putting it into the same function. So this would be f of, what's f of x? Square root of x minus 2. Remember, f of an expression equals the square root of an expression minus 2. So this is the expression now that we got to plug in here. So this would end up being the square root of the square root of x minus 2. That's the expression minus 2, like that. Okay, so this ends up being that final function. You can't really simplify this anymore here. Right, so we got the square root of x minus 2 minus 2. Now what makes this one a little bit tougher is kind of dealing with the domain, because we got two square roots and one of the square roots is within another square root, so it could get a little bit more complex. The way I like to look at this is I first start with the smaller square roots. So I know for sure that x minus 2 has to be greater than or equal to 0. Because if the expression x minus 2 is negative, then the function is going to fail, quote unquote, at this portion here. You're not going to be able to square root a negative. So it's going to be undefined at that point. So for this part, we know x has to be greater than or equal to 2. So that has to happen for sure. Now, whether we're going to get more strict on this domain from the bigger square root, we don't know yet. We're going to figure that out in a sec, but I do know for sure x has to be greater than or equal to 2 all the time in this function, or else it's going to be undefined. But let's see if we get more of a restriction with that bigger square root. So notice that we got the square root of a whole expression there, right? If we're looking at the bigger square root, so that whole expression, square root of x minus 2 minus 2, has to be greater than or equal to 0. This whole expression has to be greater than or equal to 0 as well. So we got to look at the restrictions on this. So what we would do, we would say the square root of x minus 2 has to be greater than or equal to 2. Square both sides to get rid of that square root. So that means x minus 2 has to be greater than or equal to 4. So that means x has to be greater than or equal to 6. And so notice that this is a more strict domain than x is greater than or equal to 2. Here, we're saying that if we show this on a number line, we got 0 here. Here we're saying that all the x values have to be greater than or equal to 2. But if we combine this, this is saying that all the x values have to be greater than or equal to 6. Right? Which is more strict. So this is going to be the domain. So for example, okay, if x is less than 2, we already know it's going to fail here, right? At that small square root. But now let's pick something between 2 and 6. Let's say we plug in an x value of 4, for example. Well, if we plug in an x value of 4 here, we'll have 4 minus 2, which would be the square root of 2, which is some kind of number. I forget what the number is. I think it's like 1 point. Anyway, doesn't matter. But square root of 2, that is fine. We could square root a positive number. But the fact that we have a minus 2 here, this, the square root of 2, we know is less than 2. So here we know that we're going to end up getting a negative number in that expression. Right? Square root of 2 minus 2 is going to be a negative number. So even though this small square root, we had a positive number under it, in the big square root, we're going to end up having a negative number. And so that's why x has to be greater than or equal to 6. Because those x values are not only going to allow the small square root to be positive, it's going to allow the big square root to be positive as well. So that would be the domain right there. And so that's why it's important to look at all the square roots in a certain function that you're dealing with, especially if you're combining square roots. So the domain for this function would be XCR. X has to be greater than or equal to 6. Or in interval notation, x is an element from 6 to positive infinity. And it could be inclusive of the 6, because notice if we plug in 6, we'll have 6 minus 2, which is 4. Square root of 4 is 2. Minus 2 is 0, and the square root of 0 is just 0. So at an x value of 6, this whole function is going to be 0. And then all the x values have to be greater than or equal to 6. All right, so just be careful, because sometimes you might get a multiple choice question. This might be one of the choices for the domain, but that would be incorrect. It would have to be this one. This one is more strict. And then finally, we got g of g. So let's erase all of this. And this one's actually going to be really easy because it's just a linear function. So we're putting a linear function inside another linear function. So g of g is like g of x, which is like g of x plus 5. Remember, g of an expression is equal to that expression plus 5. So this would just end up equaling x plus 5, that expression, plus that 5, which would just be x plus 10, which is just a line. And so we know the domain is XCR. And in interval notation, it would be x is an element from negative infinity to positive infinity. Right, so it's really that f of f. That was the toughest part for these specific functions. Right, so g of g would end up just being a linear function, and that's the domain in both types of notation.